the company's CTO, Michael Kagan, to tell us about the work they're doing on quantum and the AI factory of the future. Michael, checking you can hear us okay? Hello, Michael. Fantastic, thank you. I'm going to leave the stage now, and let's give you a round of applause to get you started.
Okay, so thank you for introduction. I'm sorry I couldn't join live at the conference, so I'm doing it virtual. We are in the virtual world. We'll talk about this. So I'm Michael Kagan, I'm NVIDIA CTO. I joined NVIDIA through Mellanox acquisition, which was the Israeli high-performance internet company. And I'll talk about AI factory in the future and how do we move forward. So just computing was invented about 70 years ago. And the first computer that was built by IBM, and Thomas Watson, who was the president of the IBM, said that there may be a world market of 5 computers. So what was underlying assumption is that the computing is actually developed and used for very specific and very narrow usage. And actually, the 70 years later, which is the lifespan of a human, 20 billion computers were sold just last year. And the reason is moved from maybe 5 to 20 billion is because computer becomes our tool, and computing actually becomes the foundation of the modern society. So computers enables us to connect together and to work together and to work more efficiently together. And this work actually generates new demand for new services or new applications that in turn demand more and more computing. And this is the sort of the cycle of moving forward brought us to the point of Internet of Things. And the Internet of Things, the interesting thing about it is that out of 20 billion computers that were sold last year, only a small fraction of it was actually perceived as a computers. Most of this vast majority was sold as appliances, as devices, as watches, as kitchen appliances, TVs, and so on. So we are in the era of Internet of Things, where we generate data and use this data on. So Steve Jobs, with one of his interviews, called man as that humans are actually tool makers. We are making tools that will accelerate and enhance our ability and our abilities. And he brought an example as a bicycle, which actually the tool that makes human to be the most efficient one to move the unit of mass to the unit of distance. And the computer is the bicycle of mind. The computer has become bicycle of mind because it drove the more and more innovation, and this innovation drove to the more demand of computing. And it started with the von Neumann machine, and at some point, von Neumann machines didn't meet the demand of computing, so accelerated computing came in, and NVIDIA was pioneering accelerating computing by introducing the GPU that was for graphics and for visualization. And further down, this is the computing moved to the parallel clusters, which is sort of scaling out from one machine to multiple machines. And with more computing and more data generating, there's a new way of processing the data, which is machine learning or artificial intelligence. So basically, there is the more and more demand for computing, and when current technology doesn't meet the demand, the new technology is invented, and actually there is a sort of relay race of computing technologies, and now we are at the era of artificial intelligence or machine learning. This is where we are today. So the artificial intelligence and machine learning was inspired by studies of the human brain, And the human brain is actually the most fascinating computer. It enables us to perceive the world through our senses, being audio, sight, tone, body language, culture, and we learn, and the learning and understanding the world actually accumulated inside a human brain, and it helps and enables to learn further and perceive further the world. And with this learning that we accumulate, we actually can express. We can recall it and express verbally what we have seen. We can draw our impressions of the meetings and the picture, and we can actually say or express in one language something that we learned in the other language. So this is the heart of the Transformers model, the AI model that enables us now to basically build magic services, absolutely fascinating services that you can do stuff like real-time language translation. And you can have a phone that I talk here in English and you can hear it in German or any other language on the other side. So it's sort of virtual reality, and also video conference is going to be transformed this way. So we can have not only the textual or audio translation, but also visual and even body language translation. So the initial machine learning was done with the labeled data, but recently there was developed a technology to do the semi-automated or automated learning, where you actually do the training of the machine similar way as human learns the world. Like you feed the machine with the text, you omit a few words, and you train the model to be able to reconstruct the right word. And of course, there was benchmarks developed, and it was moving further and further. And today, the size of the model, the amount of parameters, and the size of the model and the complexity of the model doubles actually every 2 to 3 months. The most recent model that was developed, this is the sort of digital brain, is about 2 trillion parameters. And of course, such a thing cannot fit on any home computer, and it requires more and more computing. And actually, this is what we call AI factories that actually manufacture intelligence. We get the data, we feed this factory with the data, and it actually gets the insights, it generates the intelligence. This is the insights and understanding of what perceived. Now, these machines are huge. It's not a single machine, it's not a few tens of machines. It's actually the entire data center becomes the computer. And we need to reimagine the data center. It's actually, it's not a warehouse that sells computing by MIPS and storage by gigabytes. It's a new unit of computing, and it is the multiple compute units that are integrated together with the software and right hardware. It's software and hardware integration. And actually the CPU, as we know it from last century, is moving from being central processing unit to be the computational periphery. And the software and hardware integration, what makes the data center to be a computer. And you can solve and actually create new magic services that we didn't even imagine that were possible just a few years ago or a decade ago. And it's, of course, it brings up more challenges. And one of the services that I want to show you is, or explain how it works, is not the services that are facing to the customers directly, but service that enables to operate and enables to deploy these huge factories. And this is about security. The services are actually running in the data center, and data center becomes the computer, and actually it's the infrastructure of society. And the amount of cyber attacks that basically can paralyze the operation of the facility, of factory, of even the country. there is one of 40 organizations impacted, and there is no assurance that can cover the losses. And it takes almost a year just to identify that you've been attacked, and usually this is a result of attacker actually showing up, demanding money or some other some other effect of this of his attack. And now, after this attack was identified, actually we now know that the data center was attacked. Now we build the remedy for this specific attacker. So the challenge here is not only that the classical, like antivirus attacks are based on known signature of the cyber attack, and the trick is, or the challenge is, to identify attack that is unknown yet, not known attack that we know how to identify and how to detect it and how to block it, but something which is unknown, that nobody knows how to do it. We actually deploy machine learning and AI technology to solve this problem or to address this problem of mitigation of the cybersecurity attack. So the challenge is to identify unknown threats. And what we are doing, we are actually building the AI models that would that algorithmically generate AI model per every combination of user, machine, and application. So we use some unsupervised training to build multiple models on each combination, and it takes about a few hours to train this model. And once we train the model, we actually start to infer the model, and we can identify these models. We can identify one of these models can identify some unusual behavior, some anomaly in the behavior, and this can flag brought to attention of the data center management, or even automatically disable the attacker. It's actually enabled us to identify attacks in our own data centers. And this is the infrastructure platform that doing the real-time data processing. And once we identify and build the model, now we need to figure out whether it works. So the way we do it, we are building for every data center, we are building its digital twin, so which we can simulate our data center very accurately, and we can exercise or test the resiliency of the data center on this model. So, and the reason I showed is that it is actually the new way of detecting and protecting your data centers. And that it is just yet another services on yet another usage or yet another way of using the intelligence that we generate and create in the data center, basically transforming data to information. So the data center is a new unit of computing, and as we, history sort of repeats itself. And with this new unit of computing needs its own accelerator. And what we expect, the accelerator of the data center would be actually quantum computer. The quantum computer enables sort of a new dimension of computing. It enables us to solve the problem that are not solvable by the current computing or data processing technology. It opens, of course, it will open up opportunity to generate new services that we don't even imagine today. The heart of the quantum computing is the qubits, and this is what physicists are working on to enable more and more qubits to be used by the quantum computer. In the last decade, there was a fairly remarkable progress on the quantum computing from few big qubits 10 years ago. Today, there's a quantum computers of tens or even sometimes hundreds of the qubits. But in order to make the leapfrog And to leap ahead and enable a new type of computer, we need thousands of qubits of error-corrected qubits, which means that we need hundreds of thousands or a million real qubits to generate this error-corrected, thousands of error-corrected qubits, and this will bring us to the quantum advantage. Now, quantum computing, as any other accelerator, and actually true for GPUs as well in the history, is that you need to rebuild or change the algorithm of your program and basically build a new algorithm to take advantage of this accelerator, and it takes time. And what we want to be in the position that when quantum computer becomes a viable machine in terms of number of qubits available, we will have the software developed and ready to go with the new algorithms that this technology will enable us to do. And what we have done at NVIDIA, again, it's also based on neural networks and AI technology. We build the GPU accelerated quantum circuit simulations, and we can simulate tens of thousands of qubits today. Of course, it's much slower than it would be on the real quantum computer, but it is fast enough. So scientists and software developers can actually use this accelerator to build the algorithms to be ready with the software for the quantum computing. So we can simulate the qubits, and we can build the quantum accelerator and its interface with a classical computer. Quantum computer is not going to be on its own. It's the accelerator of the classical computer. And we can compare it, or it's very similar to what we do on every big project, that we are actually simulate the project on some simulators, be it VLSI project or be it any other project, simulate it on the simulator to assure that it works right. And then when we build the real thing, it actually works because we have debugged and looked at it and developed it at the earlier stages. So now going back to the world, after wider world, after these things that Stephen Hawking said that the biggest advantage of humanity is ability to communicate, and we just need to keep talking. We need to keep moving forward with the communication. And what communication can do in the future, we cannot imagine today in the computing technology actually accelerating the communication. Internet Web 2.0 actually moved the humanity forward, and whatever we take as granted today, it was not even imaginable maybe 20 years ago. Just when Bell was invented the telegraph 150 years ago, nobody could imagine that about a century later, everyone can talk across the globe with everybody else. And video conference application that was invented or introduced in about 30 years ago, don't think that people imagine that we will be able to do conferences even like this one just 30 years later. What we are today, the 2D internet is actually capitalizes or taps on two basic senses, which is sight and audio. And there's a lot of other senses that we will be able to transfer over the internet, like body language. We will not have the true video transmission, but we will have the reconstructed image on the other side that actually will help me to convey the message by body language that is generated on the other side to have the message on, and of course be able to translate the language, and each one can get the personalized avatar to deliver the message. So we are moving from the two-dimensional internet, we are moving to the three-dimensional internet, which is metaverse. And we at NVIDIA building the computing platform for this three-dimensional internet for the metaverse, called it Omniverse. It is Web 3.0 that will have the virtual worlds, and we will build these virtual worlds and interact in these virtual worlds. And we can be able to communicate not just using our basic sights and sound, but we can communicate. It will be the Internet of Senses. So from the Internet of Things, we are moving to the Internet of Senses, three-dimensional internet. That's pretty much concludes my talk. Thank you very much for your attention.
Michael Kagan there, the CTO of NVIDIA. Thank you, Michael, for that thrilling presentation. And thanks for joining us virtually.